This is a report tutorial from Precision Analytical. We're going to look at a case study for a dried urine test for comprehensive hormones, our Dutch test, but we're going to look at one that has the cycle mapping option added, which is something that we've just released that is intended to assist in particularly challenging cases for premenopausal women. So in this particular case, this is the cycle mapping data that would go along with our regular report, which we'll show here in a minute. So we've got a 41-day cycle in this case. Now, previous cycles were 35 days, 34 days, 41, and 32. So between 32 and 41 days, so with that big of a gap to guess when ovulation's happening and when you should be testing, it's rather challenging. So this data is really helpful to add to the picture. So what we have the patients doing here is collecting first morning samples throughout the cycle, and then around the time where the luteal phase is supposed to be happening, which represents this sample right here, they're actually collecting a series of 4 samples over 4 days from which we can get all of the more complex data, but then we're also able to generate this data to help interpret what's going on with the particular cycle. And what you can see in the black lines here are essentially the reference ranges if the cycle is normal in terms of its timing. So you expect to see this big surge of estrogen around ovulation. And then following ovulation, then you're going to get a big surge, hopefully, of progesterone. So in this particular case, you can see that estrogen surge coming around day 26. Now, what that sample actually represents is a sample taken on day 25 and a sample taken on day 27 averaged together. So either on day 25, 26, or 27, you probably have a somewhat significantly higher estrogen peak than what you see here because it's an average of 2 days separated by a day. And then those levels come back down, and as they do, we see the progesterone levels coming up to very strong levels. So for progesterone, there are 2 primary metabolites. We monitor them both. The best reflection of progesterone is probably sort of an average of the 2. Same with the estrogens. We're measuring estradiol and estrone, which are the 2 estrogens that fluctuate the most with the cycle. If you look at E3, estriol, and some of the metabolites, they don't actually have these big ups and downs as E1 and E2 do. So these are the most important hormones for us to monitor, and from this we can see that yes, ovulation's happening, but it's shifted to the right about 11 days, and following that there's good, strong progesterone production. And again, because there's a plus or minus 10 days here in terms of where those cycles are ending up, trying to identify what's going on with progesterone and estrogen is rather difficult, so this really gives us a lot of rich information. So now we want to keep in mind that as we look at the rest of this data, it is captured here in what ends up being the follicular phase, the first half of the cycle, even though we're attempting to collect it in the luteal phase, so we have to put that in the proper context. When we look at progesterone, we can see that the levels of progesterone are low. But that's expected because ovulation hasn't happened yet. So we again see really high progesterone levels. They just come much later. When we look at the estrogen levels, they are reasonably high. And this could be a little bit tricky to interpret because as you hit that ovulation time, and this ended up being prior to that, you can get elevated levels not because you have too much estrogen, but just because you're starting to ovulate, at which point you expect a lot of estrogen. When we look at the metabolites, what we're looking at is relative distribution of these estrogens. What we normally see is about 70% 2-hydroxylation, 10% 4, and 20% 16. In this case, there's an overproduction of the 2 at 78%, somewhat of an overproduction of the 4, and then an underproduction of the 16. So the estrogen's tending to push down these 2 pathways primarily. Now the 2-hydroxy pathway is great because it seems to have more protective properties, whereas the 4-hydroxy pathway is one you don't want to see predominate too much because the metabolites have the capacity to damage DNA. Now, to keep them from doing that, we'd rather get rid of them by way of methylation. To evaluate methylation, we look at the conversion of the 2-hydroxy to the 2-methoxy. So that's the same conversion the 4-hydroxy is undergoing as well. The metabolites are just a lot more difficult to measure for the 4. So we look at this, we see the 2-hydroxy is at 4.4. Usually, the methylated product is around half of that, so we'd expect it to be around 2.2, and it's at 3. So that's relatively high methylation conversion. So whatever spills down that 2-hydroxy pathway is pretty efficiently getting methylated. So methylation looks very good. When we look at the androgens, we want to look carefully here because there are symptoms of excess androgens. So we'll look at DHEA. For DHEA, we've got 3 markers. We've got the sulfate, which is your normal marker that you'd see in saliva potentially or in blood. And it's low normal. Now the nice thing about a urine test is you can also measure the downstream metabolites. So you can see here that there is actually a lot of DHEA. It's just mostly getting pushed down to these metabolites. So if you'll see how big these numbers are, these are very abundant metabolites of DHEA, the most abundant, and so they really tell us that there is actually an abundance of DHEA being made. In spite of that, there doesn't look to be a ton of testosterone. It's right at the low end of the range. But then as we look at the testosterone metabolites, they're definitely quite a bit higher. So, it's possible that that there's a little bit more testosterone production than is reflected in the testosterone itself. But definitely the testosterone is your primary marker for testosterone. But the metabolites can sometimes aid in piecing together, what's really going on with a patient. But the primary benefit of the metabolites is that we can see that both of the metabolites on the left, those are beta metabolites, are elevated, whereas the metabolites on the right are not. So there's really a preference for 5-beta metabolism, so the 5-alpha activity is low. Why is that significant? Well, we've got a patient with high androgen symptoms. If you have your testosterone, which is androgenic, going down the alpha pathway, it gets 3 times more androgenic as you make DHT. But in this particular case, most of it's heading down the beta pathway and making non-androgenic metabolites. So then, it's not likely that DHT is the culprit for the high androgen symptoms. If it was, treatments like saw palmetto and stinging nettles and things like that would make sense because they push away from the alpha and towards the beta. In this case, the only thing that really corresponds with high androgen symptoms is the abundance of DHEA, and that might be worth exploring. When we look at the cortisol picture for this particular patient, we start with the free cortisol pattern. And keep in mind, this is normally done over one day. In this particular case, it's not. It's done over the course of 4 days. But these numbers stay pretty stable from day to day. And so it's a great way to look at what the cortisol pattern is. In the early morning, it's bouncing up nicely. And then in the afternoon, it's dropping down. If there was afternoon fatigue, that's a little bit on the low side. At bedtime, you're expecting that level to be relatively low. And then overnight, the levels are on the lower side, which is not necessarily a bad thing because you want your cortisol to drop down while you're sleeping. That's the sample that we're also measuring melatonin off of, so you can see that as well. So the concept here is to establish the free pattern, evaluate it for dysfunction, and then we integrate the area under the curve to give essentially a 24-hour urine-free cortisol. That's this value here. So comfortably within normal, on the lower side of normal, but comfortably within normal. And that tells us circulating cortisol. It's tempting to think that that also represents cortisol production, but it really doesn't. Free cortisol is only about 1% of total production, whereas the metabolites that are downstream really tell a better story in terms of how much cortisol is being produced throughout the day. And this is actually on the higher side of normal. So there's a good amount of cortisol being produced. The last part of this is where we evaluate those metabolites to see, are there more cortisol metabolites, the active form, or cortisone metabolites, the deactivated form of cortisol. And we can see that there's somewhat of a preference towards keeping the cortisol in its active form, and whether that's good or bad somewhat depends on whether the overall cortisol picture is high or low. And so you want to put this whole picture together to evaluate what's going on with a particular patient's cortisol. So I hope that's been helpful. If you have any questions, we do have a video library with a number of videos that can be helpful in just trying to put together a proper understanding of what's going on. So we've got a hormone tutorial series, as well as a number of videos, some of which will be hyperlinked from within the report. So I appreciate your time, and we look forward to continuing to work with you.